This video is sponsored by PCBWay. In a recent video, I showed how I made a 3D printed extension for my PC power button, which saved me from having to reach all the way up to turn my PC on and off. And I got some really interesting comments that got me thinking about different ways I could have gone about this. So, in this video, I'm going to show you how I upgraded my last version into this. A wireless PC switch extender that lets me turn on my computer from a distance and looks a whole lot better. And before we jump into the project, guys, all the resources for this project, the CAD files, the code and circuit diagrams, everything will be available on my website. There will be a link in the description below, so if you want a little bit more information, be sure to go check it out there. So to get started, there are two main parts to this project. There's the button itself and the receiver. And similar to most of my projects, it always starts with choosing the right microcontroller. And for this project, we're going to be using a personal favourite, the Xiao boards from Seed Studio. I absolutely love these microcontrollers, mainly because they're so small, which makes them really good to use for so many different projects. But most importantly for this project, they both have ESP32 chips on them, and we'll come back to why this is important later on. So the receiver part of the project is basically the Xiao board with three main connections. It's going to be powered by the motherboard's ATX cable, meaning that even if my computer is off, the Seed will still be receiving power, which means I can use it to turn it on and off. It's also connected to the power switch pins. These are the pins you actually short momentarily to turn the computer on. And lastly, I'm going to be making use of the power OK pin on the ATX cable. This is going to tell the microcontroller whether the computer is actually on or off, and that's a feature we'll make use of a little bit later on. So the button part of this project is fairly simple. We have our microcontroller, same as the receiver. And then we've got this nice switch that I actually used in the original project that I'm going to be reusing for this one. And we're going to be using this NeoPixel LED ring to add some visual appeal. Now you might remember me saying earlier on that the ESP chips are really important in this project. Well, that's because these boards are going to communicate with each other via ESP now. This is a wireless protocol that's exclusive to ESP chips, and it basically allows them to talk to each other independently of anything else. So that means we can have wireless communication, no messy wires, won't need any long 3D prints or anything like that, and it will just be a lot more compact. So as always, the first step is to get some prototypes together to make sure that this actually works. The first step was to confirm that the ATX cable was powering the receiver Seed as needed, so I stripped the relevant cables and teed off using some jumper wires. And to do this, I bought an ATX extender just in case I damage it, my main ATX cable will be safe. Once the ATX was in place, I used my multimeter and confirmed that I was getting 5 volts, which is a good start. And my Seed board was getting powered on even when my computer was turned off, so everything was headed in the right direction. Then I moved on to getting these circuits put together on a couple of breadboards. The circuit diagram that I used will be available on my website, so be sure to check that out using the link in the description below. So up to this point everything was working absolutely fine, but then I ran into my first obstacle. So it turns out in order for me to use these Seed boards and the ESP Now protocol, I need to use these antennas that they come with, and from a form factor perspective that just wasn't working. So I decided to switch over to my second favourite, the Wemos D1 Mini. These boards don't require an antenna to speak to each other, and they're only slightly bigger than the Seed board, so I think it's a good enough compromise, I think. And so with the breadboards put together, it was time to get everything connected and see if it was going to work. And despite a few hiccups along the way, everything was working as intended. So when the button breadboard is connected, the LED starts flashing red, which means it's in standby mode, and then when I press a button it goes green, meaning the PC is on, which means I'm able to turn my computer on and off remotely. So I was really happy at this point and I was ready to push on. And with the prototyping stage being a huge success, it was time to make this into a more polished and complete project. So I jumped into KiCad to design a couple of circuit boards. And to bring these boards to life, I used the sponsor of today's video, PCBWay. PCBWay makes it incredibly easy to get your own circuit boards made. All you do is go onto their website, use the simple form to upload your Gerber files, configure some basic settings and place your order. My boards came about a week later and I was really happy with the quality of them. They were exactly as I designed and they made this whole project so much smoother. They also offer a whole host of other services like 3D printing, CNC machining, sheet metal work and a load of others. So if you have an idea that you want to bring to life, chances are they've got you covered. So big thanks to PCBWay for supporting this video. Be sure to check them out using the link in the description below. Now that I actually had the PCBs, I could start planning an enclosure for this project. So I jumped into Fusion 360 and after, well, a few prototypes, I managed to land on a design I was happy with. And for this project, I chose to use this lovely Galaxy Black PETG sent over by Prusa Research. They're not sponsors of this video, but they did offer to send me some filaments for my project, so a huge thank you to them for this amazing filament. Once the parts had come off the 3D printer, it was time for my favourite part of any project, the assembly. The first thing was to get everything soldered up. And I use just a little bit of hot glue just to keep the NeoPixel ring fixed from the inside and so it doesn't move. I wanted to make a diffuser ring for this project, so I bought some transparent silicone off Amazon and then I mixed in some baby powder to make it less transparent and help diffuse the light from the LEDs a bit better. And once everything was nice and mixed, I poured it into a pre-made mold that I'd made using the 3D printer. It took a couple of hours to set, and once it had fully hardened I took it out and I was left with a really nice diffuser ring that fits snugly into the top of the button. So I'm really happy with the way this turned out, guys. It actually kind of looks like a real product. Let me give you a tour of how it all works. So when you first power up the button, the LEDs will flash blue. That means it's in pairing mode and it's looking for the receiver ESP. And once it finds the receiver but the PC is still powered off, it will start flashing red. and then the light changes to green once you power the PC on to let you know from a distance that everything's on and working. And guys, if you enjoyed this video, be sure to check out my other video where I make this space mouse to try and make my CAD workflow a little bit easier. And that's going to do it for this video, guys. I hope you enjoyed this one. Thanks for hanging out. Let me know your thoughts and how you think this could have been improved down in the comments below, and I'll catch you all next time.